Wendy, do you think we have about everybody?
I probably give it about a minute. I think there's 18 participants. What do you think? Maybe give it another minute. I have 104. I don't know about everyone else. I don't know. What do you think? Maybe another minute and we'll get going.
The PowerPoint's up, correct?
Yep.
Okay.
Yep, we see it.
Okay, I'll give it one more minute and then I think we'll kick it off and get the party going, right? All right, I think we'll get going, and I'd like to again welcome everybody to the National Center for Next Generation Manufacturing webinar series. My name is Karen Wosczyna-Birch. I'm the principal investigator as well as the executive director of our center. And those of you who may be familiar with National Science Foundation funding, this center is actually funded through the Advanced Technological Education division. So we're very excited to be recognized as one right now of 5 national centers, but the only center that's focused on next generation manufacturing. So before I turn the webinar over to our esteemed presenters, who are also leads on our center, I'd like to give you a little bit of a background on really the national generation, the Next Generation Manufacturing Center itself, and really the umbrella under which it's administered within Connecticut state colleges and universities. So some of you may be familiar with Connecticut and the fact that we have a fairly unique infrastructure called the College of Technology. It actually represents all of our 12 public community colleges with 10 university partners. And our goal really is to address workforce needs and really use a stackable credential model where we can take micro-credentials to certificates, to associate's degrees, so students can really hit the ground running in the workforce, but at the same time, it provides them with careers so that they can, if they so choose, go on and apply all of their credits to articulated agreements that we have with our university partners. We work very closely too with 2 relatively new initiatives in Connecticut. One is the Office of Workforce Strategies. It's directly under our governor, Governor Lamont, and also our Governor's Workforce Council. and representatives in Connecticut were members of both of those groups. And it really helps us keep our finger on the pulse with respect to what's going on in manufacturing, in as much, and I will say in as much as it's focused on Connecticut, a lot of the partners there are nationally and globally renowned companies like United Technologies. We have Stanley Black & Decker, just to name a few. But I think what's nice too, especially with community colleges, we look at the whole supply chain, so, we have several hundred small manufacturing companies that feed into that supply chain. So what we've always been focused on industry-driven curriculum, and this COT model was really the umbrella under which we were successfully able to secure funding for a regional center. And from that, ultimately, we now are very proud to say that we're actually taking the fiduciary lead, let's say, and providing leadership for the National Center, but certainly we have partners that are really playing key roles, and you're going to learn today about Mechatronics and basically, just the Central Community College initiatives that are really very, very critical to our center. So I think I'll do the next slide. I don't know if I want to get into more of the industry curriculum. So anyway, the National Science Foundation funding, again, recognized historically that COT as our national model. We've been funding since 2004 for the creation of a regional center, which, by the way, we just closed it in December of 2021. And then last spring, we received the $7.5 million for our national center, again, focused on next generation manufacturing, but really, I think a real theme throughout the proposal was looking at Industry 4.0 and all the different components of Industry 4.0 relative to the disciplines that really address manufacturing and its automation and how advanced it is now from even, say, 10 years ago. So here are the goals of our Next Generation Manufacturing Center. We're developing a national manufacturing leadership network. We're creating an advanced manufacturing education repository. We're going to be providing instructor and faculty professional development. And we want to also address the image of advanced manufacturing. I know that's been a challenge going back to when we had our regional center. We still struggle with making sure that, our students, their parents, counselors, educators, government officials, that they really understand that, manufacturing is not, as they say, your grandfather's manufacturing. It's very clean. It's really becoming very automated and requiring more advanced skills. And certainly too, we want to address a diverse workforce. We really need to look at having underrepresented populations choose manufacturing as a career path. Our partners are College of the Canyons in California, Columbus State Community College in Ohio, Central Community College in Nebraska, Indian River State College in Florida. And again, we have other community colleges that are part of our teams, but all those institutions with their leadership were co-PIs on the proposal when it was submitted and now subsequently awarded. We also have relationships, are really going to be tapping into the MEPs, and FLATE, which is in Florida, is assisting with that. And we have a number of consultants, again, addressing diversity. And we would be remiss if we didn't be connecting with our Manufacturing USA Institutes, of which on several, we actually are members of workforce committees, and all the other NSF-ATE national centers and projects, that have already been funded. And I don't want to, and if you don't have an NSF grant, that doesn't mean you're not part of this community. I think what's real important here is that we're really looking at manufacturing across the United States. And we want to also be able to identify promising practices, things that you're doing that we can also promote and disseminate. And also, it's possible we can also provide some additional support. And last but not least, NSF-ATE grants are all about working with industry and addressing workforce needs. So we're using, it's called the BUILT model, to ensure that we're connecting with industry and that they play a key role that they're not just coming to a meeting, once or twice a month and, having coffee and donuts, that we really want their input. We really want to take a look at skill standards and what is really necessary to ensure that our students are really going to have the skill sets necessary for a 21st century workforce. So with that, I think that this is basically showing you the different design teams. Well, I'm sorry, the technology teams that our center has really crafted and have leadership from across the United States addressing these areas. So design team, which is going to be looking at CAD and additive and laser scanning, reverse engineering. Our fabrication team, which is going to be looking at CNC machining, welding. Our processing team, which is mechatronics, robotics, motion, and automation, which is what we're going to be featuring today. But then also under this umbrella is industrial maintenance, laser fiber optics, and some biomanufacturing. Next is going to be supply chain, logistics, and quality control. And last but not least is an Industry 4.0 team that's going to be looking at virtual and augmented reality, smart manufacturing, cybersecurity, and the Internet of Things that you read about frequently. So what I did want to mention was we have 5 webinars. We've already completed, the supply chain and logistics and quality control webinar. So hopefully some of you were able to attend that, but today we're going to be the processing team, which is going to have the focus on mechatronics. And then we also will be doing 3 more webinars, one on fabrication, one on design, and one on Industry 4.0. So we hope that you'll really enjoy the presentation today. I think I'm looking forward to it. I had a sneak peek at some of their slides, and I think you're just going to be very impressed with what they have to say. And we welcome all of you to be part of our future initiatives and part of our network. So with that, I believe I'll turn it over to Jerry, and I'm going to let him introduce the presenters. So Jerry, it's all yours.
Karen, I'm going to start and then I'll introduce Jerry a little bit later.
Okay, or Doug, I'm sorry. I didn't know who to turn it over to. I didn't know who flipped the quarter and who got
I'm
the
Doug
heads up.
Pauley, Associate Dean for Training and Development at the college here in Columbus, Nebraska. I've been with the college 31 years and I've worked on several NSF grants over those years. NSF is a great opportunity to network with people around the country that are really interested in growing workforce development. Our project that we're going to talk today is really called IMEC 2.0. It is a collaborative project with South Central College in Minnesota. And it really spurred because we were at a conference together and starting to talk about it and grew up the idea of it. Jerry Muller is he is a co-PI on the National Center, and I am a co-PI on this IMEC project. And we are really excited to be part of the National Center because we do have quite a bit of things that we have. We have expertise in instrumentation, mechatronics, plastic injection molding as well. And so we'll continue on with the slide now. Before I get into our project, I'll just give you a little description of what Central Community College is. We are about 200 miles across our service territory. We have 300,000 in our population. And we have 3 main campuses and then some learning centers. We're really noted for our technical programs and then academic transfer as well. Our goal for our IMEC project really is to increase the mechatronics and process instrumentation technicians in the country and create a partnerships that work with rural high schools. So we have increased, we are looking at 12 high schools around the 2 states between Nebraska and Minnesota. We've identified 6 high schools that we're piloting this program with. And Minnesota has 5. And really, it's to create a pathway within high schools to help build our mechatronics programs, our enrollment through our regular program on our campuses. This is a map of Minnesota and how their schools are spread out in rural Minnesota. There's 70 miles between the distance of their high schools right now. Nebraska, again, we have schools spread out. It's about 170 miles from one to the other. We have small schools that have high schools the size of about 120 people. And we're working with Kearney High School that has 1,500 students. So it makes a big difference on the number of students that are interested in these programs as well. 2 of these schools that we have are really high minority population. So that's kind of part of our project, as well as to integrate and incorporate more minority students into our program. And it is going very well in those 2 schools. Objective 1 is really to look at the curriculum. And what we did between the 2 schools is to go and look at our curriculum and see if we had 4 courses that were pretty similar and that would build on each other. And that's what we've done. We've identified the 4 courses, and working on those 4 courses, we are not changing the curriculum. We are keeping the same competencies, but we are changing the delivery method on how we're delivering it and the activities to build on those competencies. The course sequence that we have, the first year of the program, we rolled out concepts of electronics and intro to instrumentation. So each one of those courses are offered 1 semester. The second year of the program, we are then going to be offering programmable logic controls and industrial sensors. The third year of the program, we will be offering probably concepts of electronics and intro to programmable controls, so that people in the first year of the program can advance into the next 2 courses of the program. Our development team really made up of our faculty within the high schools, and what we are calling those faculty in the high schools are facilitators, and our faculty at the community college, but then business and industry that is part of our business and industry group that we have for the program as well.
Hello.
Jerry,
Yep. So I'm Jerry Muller, and I work for Central Community College. Prior to working here, I was at Cargill, and I did like automations and controls there. Now I've been with the college for about 5 years, and right now what I've been working on the most is the IMEC project, as well as the National Center project. So the first thing I'm going to talk about is the first course that we're offering with IMEC in the high schools. So the first course the students are taking, the picture you see on the screen right here is the trainer that they're going to build. So when the student receives this kit at their high school, it's just going to be this silver metal plate that they see in front of them. And they're going to have to follow little learning descriptions and labs that they have to put this together. So each component comes separate. They have to learn about each component, and then they install it to the board. So in this concepts of electronics class, the things they're going to learn are the different concepts of electricity. They're going to learn about basic hand tools that they have to use to put this trainer together. They're going to learn how to properly read schematics, because once they have this put together, once they have the components mounted on there, they're going to have to follow different schematics to wire different labs up so they can see when they hit the push button that maybe a light turns on. And then maybe as they learn more, maybe they'll use the potentiometer that's right up here in the right corner of the board, and they'll use this to make a light go dim to bright. So we're trying to teach all different aspects of this. So using using a meter is very critical. So that's one big thing we're trying to teach as well. So those are kind of the main things we're hitting in this course. This block up here, basically what it's for, it's just a connection point. So as they move on with the classes, when you see the next few trainers, they can take a cable and plug it into there, and they can use this board that we see on the screen and these switches to control the other trainers. So it's just an add-on from one class to the next. So the second class we're offering is an introduction to instrumentation. And in this class, the student is going to learn about controlling a process using the level, the flow, the temperature, and the pressure of the system to make things happen within the trainer. And kind of like the first class we talked about, this is all going to come in pieces. I mean, don't quote me on this, but I think roughly around that 60 to 70 different components. And the student receives all this as a kit, and they have to follow build instructions to physically put this together. There's all kinds of different components on here. So I'm just going to talk about a few of the main components that we're using. So down here in the bottom right corner is a pump. And basically what's going to happen once they get this put together, the student's going to be able to use the board that you've seen in the first picture with the switches and the push buttons. And they're going to be able to wire it into here and control this pump. The pump will start pumping. This white component up here is a proportional valve. So it's a 0 to 10 volt valve. And basically, in quick, what that means is the student, depending what voltage he sends to this valve, he can control how much it's opened or closed. So he could control it at 25%, 10%, 15%, and just depending what he sends to that component. The water will then flow into this top tank. This blue component right here, so we have two of them. They look the same by looking at the picture, but they're a little bit different. So the top one's a 2-wire control valve, and the bottom one's a 3-wire valve. And basically the difference is the top one opens, you give it a signal, it opens, you take it away, it closes. The bottom one reacts a little differently. You have to give it 2 different signals to either open it or close it. So we're trying to get as much different things on this board to teach all the different things a student could possibly see in industry. We have a flow sensor over here. We have a capacitive sensor for level up here. We have a float sensor for level in the middle tank. We have a heating element right here that will heat up and send the temperature over here to this controller so you can see what the temperature is inside that tank, and you could program it to run at a certain temperature. So that's kind of the instrument trainer. So there's a lot going on there, and we will have some questions later on if anyone has some. And then the third class, so this is just our first prototype picture. It might change in the end a little bit, but basically this is going to be our PLC trainer. So for programmable logic controllers. And basically what the student's going to do here, so the new component is this square PLC right here, okay? So it's an Allen Bradley Micro 850. And basically we're just going to teach the student how to do some basic programming. So in the first and second class, they were using these switches and push buttons and sending the wires directly to the instrument trainer to be able to open and close valves. In this class, they will be using these switches and push buttons, and they'll wire it to the PLC, and they'll have to write a little program in there so the PLC knows to send signals to the instrument trainer to open up the valves and make it run that way. So it's more of an automated version. And then our last class is our industrial sensors class. As you can see here, it's still under construction, and really the PLC class and the sensors class, we're still kind of putting all the labs and how we want the order to go for the online class to make it flow the best we can, just from what we're learning in the first 2 classes. So we're still working on it, but just to give you a quick overview, basically we're going to have a bunch of different sensors, which are listed here, and the student's going to learn, let's say when they grab the new sensor, they're going to learn how to wire the sensor. They're going to learn how to check the sensor with the meter to see if it's working properly. They're going to refer to data sheets so they can see what the manufacturer is trying to tell them on the data sheet, and they can learn how to read them, which they'll do in every class with most of the components, at least the main ones. We refer to the data sheets as much as we can. And that's kind of what they're going to learn in the sensors class. So they're going to wire them, they're going to troubleshoot if they're not working properly, and they're going to learn how to read the manufacturer specs and data sheets to figure out how they can use these in industry. So now I'm going to see if I can get this to work, and I'm going to share a different view here from my other camera. And what you're going to see is you should see the instrument trainer in the PLC right here. So we have the instrument trainer right here with the PLC, and I'm going to go turn it on. And basically what you're going to see is this PLC is programmed to turn on the pump. The water is going to pump around here, and it's going to start filling water up in this process tank. Right now I have it set, so it's going to try and maintain a water level of about 50% in there. So I'm just going to turn it on quick and let you guys see kind of what it does. So right now you can just see the water level in the holding tanks going down because the pump's pumping up and around to here. As the water fills up in this process tank and gets closer to that 50% mark, this valve should start to close down to help regulate the level in this tank. So we should see the water start slowing down out here. So it's going to try and maintain that level right there. So this is kind of the end solution. Once they get done with PLCs and stuff, they'll get to do all kinds of little labs where they're programming the Allen Bradley PLC right here to control the system over here.
So our second objective is to have a business and industry leadership team that we have had for the last year and a half, 2 years on this project. And our industry team has really been very, very valuable to us as we develop this program. First, the industry has told us they really wanted hands-on training. And so we are trying to make as much hands-on as possible, and that's why we're having the students assemble those pieces from the very beginning. And at the end of the class, they'll tear it down for next year's class so that they can build them as well. Industry, as they see this going on, they're continuing to give us improvement suggestions. The industry folks are also acting as professional development people, mentors for some of our high school facilitators as well. Those industry folks are going in and doing presentations. They're also doing tours. They're talking to these students about what they can make in a career in this field as well. And then the sustainability part of it, they are also very excited and willing to help fund some of these programs. We have schools that are paying tuition, or businesses that are helping pay the tuition or the fees for those programs. Some of the companies are reimbursing us so that we can buy additional trainers for the high schools because they want them, each student to have it, have one to work on themselves.
We also had a few companies that started a scholarship type program, and they're kind of using our IMEC program as a pipeline. So they might go in and pick a few students each year and give them a full scholarship to Central Community College for Mechatronics. And then the student signs like a 2-year agreement with them. So that's just some stuff that's been going on with the program as well. So they're helping in a lot of different ways. We have a few of our built members that are helping with just the equipment, like Doug said, and they might be helping us out on products and getting us the products we need to make this more of a cost-effective training.
So here's some of the partners that we've gotten thus far in the project. And like Jerry said, they've been very excited about the project. They think this is a program that is at least exposing the mechatronics to high school students, because in most cases, high schools don't know, or students don't know what mechatronics techs do. But here, Rockwell Automation has been a huge partner with us on the project. Fluke, Cato Cable has been working with us on getting the cables all cut to the right size. Klein Tool has helped us with some cost on some of the tools. Cargill has helped to fund equipment because we had one school that had 40 kids that was interested in it, so we needed additional trainers as well. Buffalo County Economic Development is helping pay fees for some of them. Border States is our vendor that we're getting our Rockwell stuff through and other components. So we have a lot of great partners in the program, and these people are all part of our BUILT committee as well. Objective 3 was to recruit our high school students and identify the 6 schools in each of our states, and then assign them. And so we went out and we found the 6 schools that we wanted to work with, but the schools had to commit to having a facilitator in the classroom. The facilitator really is the high school teacher, but they are not the instructor of record for college credit, primarily because they don't have the industry experience that we're requiring in a community college to teach those classes. But they are a very critical component in our program to make sure that they make sure that students are staying on track as well. They have to commit to a classroom for us and storage space to store this equipment, because as you can see from Jerry, there's quite a bit of equipment that they have to be able to store as well. They had to have computers available to the students, and marketing the classes to their students. We look at it as really a marketing opportunity to expose students to the careers. And then they had to agree to offer at least one course each semester, the first year and the second year. And then also attend professional development at the end. This past year, we had 6 days of professional development for the teachers. We did 3 days on instrumentation and 3 days on the concepts of electronics. And that was really very beneficial to us because they could give us feedback as we were developing the course. They actually built all the trainers from scratch as well, just like their students would, and looked at some of the things that we have developed thus far in the program before we were ready to launch it. This year, we're going to do 4 days of professional development for them.
So this slide here is just showing a picture here of a white glove videos. And I guess that's kind of the term that got labeled for all our videos we were doing. So when we're trying to teach the student something, since we're not in the classroom with them and we're more of the content expert than the facilitator is, we've been creating these videos that could be anywhere from 2 to 5 minutes. And our new thing is we're wearing these white gloves with people's logos on them. And the students really seem, we have heard comments like, I wonder what the white glove video is today, or I can't wait to see the white glove video for tomorrow. So it's kind of a new hit thing, at least in the students' eyes.
One of the things that we did with these white glove videos, we started having longer. The faculty thought that we needed to do full-blown lectures of 20 minutes or so, and the students and the high school facilitators said, you're never going to keep the students, you're going to lose them right away. And so that's when we switched back to the 3-minute videos, 4-minute videos, something like that. And so we can take each component and highlight it. They can do their lab relating to that and then move on. I thought it was important for other schools and colleges out there to think about some of these things. And so I wanted to list some of the best practices that we've learned over the last 1.5 to 2 years. And hopefully if you decide to do something like this with STS programs on web-based courses. You can learn from them and help make your program better. Selecting the facilitators is one of the critical components of the program. You have to have somebody that has a passion, that wants to learn, wants to help those students out a lot. The hands-on training, again, was very, very important, so that the students can do some of that critical thinking as well as they start building those units. The industry people, identifying adjunct instructors. One of the things we found out about the web-based course is that it allowed us to get more industry people involved in the curriculum, because if they had to be here to teach a class in person, it didn't work in their schedule. But if they were doing something with a web-based and they could do it in the evening, they were more receptive to it and open to that idea as well. Central Community College waived the tuition for the students. They have to pay the fees, but we waived the students or the tuition because we felt like really this was more of an exposure, and it is in a high demand career in Nebraska. And so we thought that we could at least expose them. They would know about it. But really we're targeting two groups of people, the ones that think they want to be engineers, and then the other ones that want to also be more the hands-on workers as well. Again, here's some more. Freeing up the faculty has been very difficult in the high school because they're already crunched for faculty in the high school. So releasing them from one of their classes to do this class was part of an issue. Using laptops versus iPads. iPads are a little bit slower in the process. Sharing grades with the high schools. The students had to sign waiver forms. Again, the storage was an issue. Building rapport with those high school facilitators and administrators was very critical and continues to be critical to keep that momentum going once we got the program rolling, and then developing those shorter videos. Getting students registered early, and if you can get them registered during the summer, it's the best, because then day one of the classes, they can start teaching it, and instead of spending a week to get their parents to sign their registration form and to get their logins and their passwords. So to get them registered early on is the best if we can do that. And the facilitators, again, in the high school, because they are really limited. We started talking about mechatronics technicians, and really we decided mechatronics are keeping the world running because they are serving so many industries. They're serving the robotics, injection molding, they are serving CNC machining, food processing. And so we have these mechatronics techs within every industry throughout the country. I'm going to have Steve Lincoln talk to you again. He's going to talk to you about some of the demand that he sees as well. And again, he is the person that really has helped us create a partnership with Rockwell, and really that we see is benefiting everybody.
Hey, thank you, Doug and team, and thanks to everybody that's joining in on this. I'll try to represent a little bit the point of view from the business and industry as Doug and team talk about built business industry leadership team and that influence. So Rockwell Automation, we're manufacturers ourselves. We manufacture many of those things that Jerry had shown. And I think another piece to say here is the vast majority, almost every one of our customers is a manufacturer as well. So when they put up the slide of the partners, they showed Mars Pet Care, or they showed Baldwin Filters. They use our products in their industry to make products, which then end up in the supply chain. So to kind of give that point of view, and we're really intrigued by this industry-driven curriculum. So as you as colleges are considering something similar to what Doug and Jerry are doing, just wanted to give you a little bit of insight into why we as a manufacturer and a supplier to manufacturers and industry think it's important. So a couple of things we'll talk about here on this slide: the struggle to keep talent, and then a couple other slides we'll get to is like the cost of that struggle, And then the change in the need for talent, it's evolving faster than ever before, which is why colleges and then reaching into high school is more important than ever before. And our reliance and our customers' industry's reliance on academia is so important. So here's a couple snapshots here just to quantify a little bit of the demand. Why do we as industry feel what you're doing, what Doug and Jerry are doing, and the National Science Foundation, et cetera, are so important? So think of, you went to the store to buy milk. What did that manufacturer, that processor, what do they struggle with every day? And so, and especially now, some of these slides are even pre-COVID. So especially even more so now, the gap that exists, talent is very hard to find. So to say 60% of our production roles go unfilled, what's the impact of that? You can take that next step of, are we not able, is that industry partner not able to introduce a new product? Could we not run fast enough because we didn't have someone to repair more quickly or introduce something? You look at me, gray and bald, and I'm kind of in this boat as well. This manufacturing workers, 21% of the talent is retiring, and it's not getting any less. We're seeing that more and more. I look at my own company, my peers, I'm getting notices every week, hey, I'm retiring, etc. So our customers and those in industry see that as a challenge, because if somebody retires, Wendy or Karen, I think Karen made the comment early of, this is not your father's or your grandfather's industry. We used to have somebody that would be in a position for 40 years, and that is evolving. And so you think of what's happened, what's in that person's brain over the course of 40 some years that is now retiring, and how does an industry partner fill that? And so the reliance on education is so much more important. And then this last one we'll also talk about on the next slide, the 75%. Things are changing so fast. You go to the next slide, Jerry, that we'll see on the following slide that even if we train somebody up 2 years from now, it's probably going to need that again. So we talk about struggles on the previous side. What is the cost of that struggle? It's not just somebody's salary. If 60% of our jobs are going unfilled, are we not able to produce? So there's that lost opportunity of production, for instance. So on the left, you have what you primarily think as an industry, we look at the cost of a person. Well, now what did we lose because we didn't have the ability to meet that need, produce that product, react more quickly? Maybe we had to pull back a shift as an industry. So now we're down to 3/4 of our ability to produce. The cost to acquire talent. That's why, Doug making the comment of industry is coming to him and coming to you as well in other colleges of, hey, we see this need. Can you help us find people? Because acquiring talent, there's a cost of time, a cost of money to do those types of things. And then once you get somebody on board, you have to bring them, train them. There's compliances. There's a lot of things that go into somebody's employment that maybe didn't exist 30 years ago. So those are things to consider. Next slide, Jerry. So kind of made this comment of the changes and the transformation that we're going to see. So industrial IoT, Wendy had mentioned IoT, Internet of Things, which is kind of an all-encompassing term, but basically saying, even the devices that Jerry had showed, they are getting smarter and they can give more information to a control system. If somebody at a business level is trying to make a decision, some of the information in that decision was created on the plant floor by a smart device that not only said, oh, I detected a box, I can also tell you I've detected 7,000 boxes in the last minute, or last hour, or whatever it is. So sensors, devices, everything is becoming interconnected. Think of your own phone, about what you can do with that now because of that information. It's all enabled by a smart device, the connectivity, how do I bring that information together? And so what's happening, this skill sets are blurring, is even when I started, or we think of the talent that's retiring. We used to be able to say, okay, you're a welder, you're an electrician, you're a mechanic. You know, all that stuff is really blurring together. Even the term mechatronics, mechanical, electric, robotics, there's a lot of things that get pulled together, and that talent tends to blur together. And the need, the industry that's coming, industry partners that are coming to you for education of people, their need is also evolving and blurring. Somebody needs to be able to have the meter to be able to test a connection, but also go into the computer to be able to program something, because when that meter or when that button was pushed, now it just didn't turn on a light. Now it started a whole other process that may have been a programmed process. So perception of industry over the years, I think, is evolving. And as things become more and more connected, you know, what we think of doing on our phone, you know, we're starting to see a lot of that happening in industry as well. And I'm a product of industry for 30 some years. I love industry. You know, it's, you know, when I walk into a different place and I kind of know how things were built, it kind of drives me behind the scenes. You know, I think, you know, how do we make that attractive also to people in high school, or take advantage of those that in high school really like to take things apart and really understand and learn and those types of things. And, you know, create that environment. And that's where we as industry really depend on academia to kind of recognize that desire and build on that desire. That K through gray is kind of an interesting comment of, hey, it starts in kindergarten for learning, and you really never end up ending your learning journey. So it's very, very important. Next slide, Jerry. And I think here is kind of to summarize how important it is. You know, we talked about the struggle, we talked about the costs of that struggle, we talk about the change in the talent that's needed over the lifetime of that person, or that need in industry. And I mean, how it's very tough. Every industry, you know, their core competency is to make milk, or to make a filter, or to roll paper, or to pump oil, or those types of things. They don't have the ability, that's not their core competency, to educate or recognize talent in a high school, recognize talent in a college, and foster that talent. So industry is very dependent on academia for recognizing that and educating in those fundamentals. So those phases there are, you know, it starts with maybe the little widget that's on the plant floor, but it has information about itself that then goes up, down, however you want to say it, but we usually say kind of plant floor, then up into a control system. It's digital. Now we have controls in this IoT, the smart sensor, and everything that comes with IoT, which I know there's another part of this series that will address that. Things getting connected, bringing contextualization of, hey, the device tested something, but now contextualizing that with the product we're running, maybe the time of year it's being run with, and being able to bring that stuff together and analyze it and then present it in visualization for somebody to make a decision on, and then maybe even integrate that up into the business systems, which a decision might be made on data halfway around the world from where that piece of data was made. So next slide, Jerry. I think that's it for me, aside from just to thank you for allowing me to speak. But again, you know, as I'm working with Jerry and Doug and Shane, one of the partners that's on the phone, of how important this is, how important our customers, industry, feel we need this education in the field, and keep that bench strength. There's not a lot of bench strength when 40-year-old employees are retiring. So thank you. And I'm happy to take questions also.
Thank you, Steve.
Wendy, I don't know if there was any questions in the chat, or if anybody has questions, we would be glad to try to answer them.
Yep, I haven't seen any yet. I'm just going to share my screen quick, and feel free to unmute yourself and ask a question if you have one. Anybody?
There was one that came in on a voltage question. Jerry, I'll let you jump into it. And I'll ask, I'll let you answer it, is what voltages do the trainers operate at? I'll let you answer it, and I'll just answer it from, thank you for the question. You know, our industry partners have seen an evolution there as well, that if we went back 20, 30 years, everything was much higher voltage. Things are evolving to lower and lower voltages, which also lend itself to trainers in high schools and college environments.
Yeah, so the voltage on the first trainer, the basic electronics trainer with the breadboards, we're using 24 volt DC. So you plug into the wall for 120, and then we have a power supply that produces 24 volts DC. And there's just a connection point like a laptop has. So there's never actually 120 volts to the trainer. So it comes out the charger at 24 volts DC. The approximate cost of that kit is around $300. So good questions.
And
Anybody
that's
else
very
have some
applicable at
questions?
24 volts, like I made the comment. You know, if we're training somebody in high school or in a college, chances are more and more of what they will deal with in the field is that lower voltage, both from a safety point of view, but just how things are moving to those voltages.
Any other questions? You guys did such a great job there that they don't have questions.
Oh, what degree is granted? One just came in.
So go ahead, Doug.
The 4 classes will lead towards a certificate if they come to the campus, but they will get an associate degree in mechatronics or instrumentation when they come to the campus and go through the rest of the program.
Another cool thing that our college is allowing us to do, so if the student signs up for all 4 classes in high school, we'll match their next 4 classes if they come here. So yes, they're paying $15 a credit hour in the high school, and then so they'll get 4 classes for the $180 total, and then we'll give them their next 4 classes for free if they come here.
Wow, that's great.
And is there an internship program with partners?
I would say, so not strictly an internship program, but we do have a few of our industry partners who are just selecting these kids out of high school. And when they come here, they know they're going to go back and work for them. And when these students do that, they are working part-time for them, but it's not set up as like a straight internship. So mostly part-time type work.
Thank you. Does Rockwell Automation provide free Studio 5000 software licenses for your program?
So we use the toolkit for our studio products, which is a discounted rate for education. And then in this particular program with the Micro 850, it does not use Studio 5000, but it uses Connected Components Workbench. And that is a free download from Rockwell. So considering that we're working with the high schools, we didn't want to get a lot of licenses involved. So we decided to use their Micro 850. And I think they'll be using a lot more of the Micro 850s in the future, the way it sounds. Maybe Steve has anything on that.
Yeah, I'll jump into that. So to your point, that PLC on that trainer is free download, Connected Components Workbench, which I didn't show. They do have Logix classes, which we do offer toolkits and that type of thing. We are looking at, for education, a virtual, more of a virtual version where somebody could log into a virtual environment for learning purposes, but wouldn't be able to access into a machine, which, you know, for a learning environment is not a bad thing. So we're contemplating that, looking at that. Doug, I know Fred had some discussions with you on that also. So that's another thing to consider, the actual education of using the software. We're trying to make that as easy as possible for as somebody who's learning, especially a high school student or who is not in front of a machine.
I think the equipment vendors have really changed their approach in the last 5 years because they recognize the shortage of workers. They know that they have to get more people trained. And so they have been, I think, more open to different opportunities and looking at things a little differently.
And I know one thing, it's using the connected components for programming, but it does have that a view in there where you can click like Studio or Logic's view, and it kind of tries to imitate it a little better than just the generic connected components version. But other than that, the toolkit, I mean, it is a reasonable cost compared to just a regular license. So that's something to look at for people who are thinking about using that software. I would definitely look into the toolkit. It's like a 1 year. It lasts 1 year and you just repurchase each year. And it's good for all their softwares.
Okay, I don't see any more questions and we're at 2 o'clock.
Well, thank you everybody for participating. That is great to have you. If you have additional questions, please get back to Karen, Jerry, or I, or Steve. We would be glad to try to answer them.
Yeah, and thank all of you. That was a great presentation. I do want to mention just one thing. I'm going to say it's like 99% approved, but it looks like this group is going to do a workshop as part of high tech. So if any of you are interested in really being able to roll up your sleeves and have the expertise of this team help you with the trainers, we would encourage you to take a look at coming to high tech. We'll send out more information to all the participants on that as well, but we're really excited about that initiative. And again, the ability for what you're doing with the trainers and all to be shared, with other educators from different parts of the country. So thanks again. So have a great Friday, great weekend, and hopefully you can join us on March 18th for the webinar on welding. So thanks again, everybody.
Thank you.
Thank you.